Dear friends, today is lesson 3. In this lesson, we will discuss about the different type of telescopes. The first telescope is a refractive telescope. That's a lens telescope, and this is discovered by Galileo. So it's called also Galileo telescope, lens telescope, Galileo telescope, refractive telescope, because the rays passes through the lens, get refracted and focus in one point. That's why it's called a refractive telescope. So these three names are the same telescope. Okay, so very simple and it can give high quality image. We will go to the next one. Is called a mirror telescope or reflective telescope. Because we are using a mirror, it reflects the light back. So this is discovered by Newton, and the light goes to the primary mirror and reflects back to the small diagonal secondary mirror. It is you will see the 45-degree angle, so that is one, and then reflected back to the eyepiece. Where is eyepiece is there? See that top vertical. That's what we look at. This is a one. Price wise is cheaper compared to refractive telescope for the same size of lens or mirror. Okay. The third one is combination of lens and mirror telescope. It's called a Cassegrain telescope. There are two variety, and when I come to that one in detail, I will discuss about those two varieties, and that gives a very high quality image and higher magnification. All right. So now the next lesson is, in the next part of this lesson is, I'm going to discuss more about particularly refractive telescope, and then magnification, how we arrive magnification for each telescope using certain eyepiece. The reason why I want to teach magnification, it is very important. I tell you why. Some object you need higher magnification to see, and some object to see you need a lower magnification. For example, if you have a binoculars, usually binoculars 10 times magnification. So through the binoculars, you can see 10 times magnification moon. It's not very big, but you can see details. Okay, but if you want go more than 10, telescope will comes in the picture, because binoculars there's a limitation, and how much we can go. See, let's see. First, we are interested to see the planets. Usually, we can see throughout the year, except a few months when the sun comes to the constellation. Moon, Jupiter, and Saturn. Okay, how about Venus and Mercury? Venus you can see either evening or morning, but there's no excitement it's looking in Venus. The reason is how much you see, it is you will see half of that size maximum, and then it's less than half, not a full type. And Mars you can see, of course, but Mars you need a very high magnification to see very details. Okay, but the small telescope you can spot out it will look color, red color, but it doesn't go very high magnification, because you need a very high powerful telescope. That's why Cassegrain comes in the picture now. Now, for higher magnification, you need some Cassegrain or like refractive Newtonian telescope to see the Saturn rings. You need at least 80 to 90x magnification to see ring. Otherwise, in binoculars you can spot where the Saturn is, but you cannot see the ring. The same way, it's a small telescope like 80 millimeter and like 400 millimeter focal length. You won't see in that one, you cannot see Saturn rings. So because you cannot go higher magnification with that particular telescope. So I have given here, I have one telescope. It's a 6-inch diameter telescope. Is a lens diameter, I mean. It's a refractive telescope. The focal length is 600 millimeter. So I see Saturn ring good. Why? If I use 40 millimeter, okay, now I don't want to confuse here. When I talk to later part of this lesson, I will talk about magnification, how to calculate, and what magnification you need to see Saturn. At the same time, there's telescope restriction also there. There is, you cannot go more than certain limit for each telescope. Okay, then what we can do, double the focal length. That also we can tell. That is called using Barlow 2x lens. Barlow lens 2x. 3x also available, 5x also available. I mean Barlow lens 2x, 3x, 5x. But 2x is commonly used for many people, so you can double the size of the focal length. That is, if you buy the 600 millimeter telescope, it can be doubled to 1200 millimeter telescope, but the same telescope, but you are using higher magnification. If you use 1200 millimeter with the Barlow lens, if you use a 10 millimeter eyepiece, to 1200 divided by 10, it is equal to 120x. That is magnification. You can easily see that Saturn ring. That's what I'm trying to tell you. So to know how it's important about the this magnification, because if I teach in one telescope, the same principle apply for any other telescopes. All you have to look at what is the focal length of the telescope and what type of eyepiece you are using, and you can use 2x to double the focal length. That's what I'm telling. For example, when I come to the Cassegrain telescope, I have one 8-inch mirror telescope. Its mirror size is 8-inch. Its focal length is 2000. As it is, it comes with that 2000 millimeter. Okay. If I use 2x Barlow, it will become a 4000 millimeter. Let us say if I use 10 millimeter eyepiece, how much I get? As it is without Barlow, 200x, right? If I use 2x Barlow, it will become 400x. You can see Saturn ring so big. Okay, that's what I'm trying to tell you. So these are all one can learn by buying the telescope. How much you can buy, it up to your financial situation. So once you get in this astronomy, it's difficult to, anybody can buy one telescope, but what happened if you really seriously into that astronomy, you will be tempted to buy more than one telescope. Okay, but so the buying telescope also very important. In between, what you can buy to see everything, only one telescope. Yes, you can buy 8-inch Newtonian telescope. You can see everything in that one. Okay, so Newton, and when I come to the Newtonian, we will talk about that. Now with this one, this part is I'm going to close this one. The next part of this lesson, I'm going to discuss about particular telescope, which is refractive telescope by Orion. Bye. So this telescope is a refractive telescope made by Orion. It cost about $250, which I bought long time back, about 15 years back. I'm still using. It's good telescope. Short tube. You see that it's not very lengthy. This lens, see here, you can see the lens. The lens diameter is 120 millimeter. That is a 6-inch diameter. So the lens diameter is 6-inch. That's quite enough. It's here you can see this objective lens focal length is written in this telescope. See here this small label. So it shows that 600 mm and f5. This is called focal ratio, f5. So f5. This lens focal length is 600. How do we calculate? For any object like this is a formula. See here, focal length equal to focal length of the objective lens is equal to lens diameter, that is a 6-inch, or 120 millimeter, times 5. This 5 comes from here. You know, f over 5, here it is focal ratio. They take the 5 multiplied by the diameter. It equal to 600 millimeter, right? So this is the focal length. This way you have to calculate. Sometimes what happen, actually this lens is little bit thicker. In the middle is more thicker. If you make it thin in the middle, the focal length will increase. What does that mean? Instead of f5, it can jump to f10. Okay, f/5, it can be turned to f over 10. So if you take the 10 multiply by this 120, so it will give 1200 millimeter. Okay, the tube will be very longer, double the size of the tube. Sometimes it's not easy to handle, because in the longer one means you need higher, the tripod height should be way high. Then only you can, otherwise it's very difficult to see the object. You want to bend too much. So that's why, but you can increase the magnification to 1200 millimeter, sorry, focal length to 1200 millimeter by using 2x Barlow lens. Okay, and I don't have a picture now. Next time, next lesson, I will talk about reflection, that is a Newtonian reflective telescope. At that time, I'll show the Barlow. Today, we will finish this lesson with this. Now, after this, okay, this is done, right? You understand. The focal length equal to lens diameter times the focal ratio, the number. that is a 5. Okay, this much you can understand now. So what is the benefit by using this lower focal length? It gives a wide area to cover. That's why it is called RFT telescope. What does it mean? Rich field telescope. Anything shorter telescope for the given lens, you can make longer telescope using the 6-inch mirror lens, but by the manufacturing process like this, the center part should be thin to get a longer focal length. If it is a little bit thicker, it will be a shorter focal length. That's why this is called a rich field. That means the shorter tube will give wide area to cover when you look at through the eyepiece. That's why it's called RFT, or rich field telescope. Okay, so, and I think I have given enough information about this. Now, from this, with these parameters, how to calculate magnification, how much you can get maximum using the telescope, and how much you can go minimum, and so and so. Okay, and I'm going to show with the 2 eyepieces in the next part of this lecture. Okay. Okay, here you can see the magnification details. So I'm using the same parameters here. What I'm using, magnification equal to focal length of the objective lens. That's a telescope lens, okay, divided by focal length of the eyepiece. So I am giving 2 examples. One is 600 millimeter, that is a telescope focal length. I'm using 40 millimeter eyepiece. Okay, in the eyepiece it will be written like this. In the next lesson, I will put those pictures also. I have many eyepiece with a different focal length. So 40 is a very standard in the higher number. Okay, that will give lower magnification. So 600 divided by 40 equal to 15x. So 15x is very good to see some objects clearly. Okay, but if 15x is not enough to see the what you call Saturn ring. You can identify the Saturn, but not the ring. But moon you can see, and some objects like Pleiades. Pleiades means Kartik star groups. In our Hindu mythology, Kartik star groups, Kartikeya Pengal, 6 sisters. They took care of baby Muruga. Everybody knows in Indian. Everybody knows it, particularly in Tamil Nadu. Every Tamilian knows this one, right? So that particular object you need not more than 20x to see those particular cluster. That particular object is called open cluster. The bright stars, 6 stars you can see, no doubt about it. But in between you can see many faint stars. So total you can see a lot of stars, like a very dark side. You can see hundreds of stars in that particular group, and very beautiful one. Okay, and in Japan they called 7 sisters. You will see the symbol, emblem of the Subaru. There is a small in the round oval shape, and in between there is some stars is there, right? That is 7 sisters. So see now we have mythology. At the same time, they also believe that. So they are using as a emblem for Subaru. Okay, Subaru company using that one. They are taking 7 sisters. There are some stars is there, 7 stars there. but we took bright stars, top bright stars, 6 stars. Okay, this is a difference between our view and the Japanese view. All right, now the second eyepiece I took here, 10 millimeter. I have 10 millimeter. I have 6 millimeter also, but I didn't give the calculation here. But a 10 millimeter eyepiece, if you use, you will get a 60x. 60x, that is barely enough to see a Saturn ring. Okay, very in small, but you can see in very clear sky, no windy. You can see that, but you can easily see, enjoy Jupiter. Jupiter with the 4 moons, good. You can see that. And moon, no doubt about it. You can see very clearly. Okay, and so what else I can teach here? I think I have covered basic basic details about the refractive telescope. In the next lesson, I will cover both, like probably a mirror telescope and Cassegrain telescope. Because mirror telescope, it doesn't take more time, so it will be small, short video. So if I cover Cassegrain, so that it will be a decent size of the video. Okay, and to buy, it's all depends upon your economic condition and availability. And so, but this telescope, one of these telescope is very, now it's telescope prices are going up, so you cannot get this particular telescope with a tripod. You cannot get for $250. You have to pay more money. Okay, the telescope tripod should be a little bit strong enough to hold that. Okay, so anytime if you buy tripod, the tripod weight should be larger than telescope weight. You should remember that. Okay, then only it will be steady. If you keep it outside, if it is weaker, wind will disturb. So the base, when you be building a house, the basement should be strong, right? The same concept. So you have to buy a good tripod. The one I have, I use many telescope in the same tripod, but they're all lighted. It can hold. But I have strong tripod also. I have one tripod that will hold very heavy telescope also. Okay. With this, I'm concluding this lesson, number 3, and see you next lesson 4 very soon. Okay, one more thing I want to tell you. I don't know how many people enjoyed this October 14th solar eclipse. I have seen from Denver. I visited Denver to visiting my daughter. So from there I was watching, about 80% covered. But in Chicago, my friends, many people did not watch because that day was cloudy. So the whole America, how many people watched? It is only visible in North America, South America. But okay, if you miss it, don't worry about that. American people can wait until April 8th, 2024 for total eclipse coming in USA. People live in St. Louis, they can see total eclipse, not from Chicago. Okay, and the map is available in the internet. The path of totality, it's given in the map. You can go to the internet, find out. The date is April 8th, 2024. Okay, thank you very much. Bye.